This is Team 27, French Toast Mafia, consisting of Jenny Brees, Austin Cronin, Susan Donaldson, Colby Robinson, and Asher Spivak. Our 2015 FEDD project was the fabric bucket. In this presentation, we will tell you our team's objective, how we use the engineering design cycle, give a summary of our research, share the various lessons we learned, and finally, give our bibliography. Our mission was to create a bucket able to travel, collapse, and hold a gallon of water for 60 seconds, and it must be made primarily of synthetic and natural materials. Determining our objective was the first step of our implementation of the engineering design cycle. Then we began researching solutions. We divided the research and design phase into 3 categories: waterproofing, structure, and aesthetics. We assigned 1 or 2 team members to each. Next, we considered the assignment's parameters. This included the bucket's height must be less than 30 inches, the area in contact with water must be roughly 50% fibrous material, and we could not use any commercial waterproof textiles. We faced 2 main obstacles. The first was to design a way to waterproof the bucket. After extensive research, we identified 3 possible solutions: petroleum jelly, a laminate, and beeswax. Petroleum jelly serves as a quick, effective solution, but its low viscosity would allow the water to push around the coating and weaken the waterproofing. Laminating also seemed to be a quick, effective solution, but some laminates could be considered a commercial material. While beeswax is fairly heavy, it is sturdy, inexpensive, and all natural. We decided beeswax was the best option. Our second obstacle was creating a structural support system for the bucket, or as we called it, a cage. After consulting various sources, we came up with 3 potential solutions. Our first option was to use a basketball net. Basketball nets are strong, inexpensive, and cover a large area, but it could be considered a prefabricated material. Our second option was to construct a cage using some form of metal or plastic. This would be strong, but not compressible. Third, we considered covering the outside of the waterproof interior with a sturdy fabric, but this may not provide enough strength or compress to the required dimensions. We decided the best option was to create a cage consisting of multiple overlapping rings made of fabric. Next, we decided to test the beeswax, and we discovered it is difficult to apply beeswax in a way that integrates it into the fabric. We determined the most effective method was to scatter the beeswax pellets across the fabric and bake it. However, using an oven would require cutting the fabric into oven-sized pieces, which didn't align with our design for a seamless interior. We decided the best solution, therefore, was to melt the beeswax over a stove and apply with a paintbrush. We used this technique in our first prototype, which consisted of a non-stretch cotton fabric coated with beeswax and supported by a multi-stripped fabric cage. The prototype held the weight of the water, but began leaking about 15 seconds into our testing. To address this problem, we decided to add a layer of petroleum jelly over the beeswax. We included this aspect in our second prototype. Our second prototype successfully held a gallon of water for 60 seconds without leaking and needed no improvements. And before we knew it, we had created our final design. Our final design features a seamless fabric interior coated with beeswax and petroleum jelly, supported by a multi-stripped fabric cage. We also included straps so that it could be worn as a backpack. Finally, we were ready to build our project. We sewed the multi-stripped cage from a simple beige cotton fabric, applied beeswax using the same method as before, and when the beeswax had dried, added a layer of petroleum jelly. Finally, we sewed the interior fabric to the cage. We were ready to compete. We poured the gallon of water into our fabric, and it held without leaking for an entire minute. When we added more water, however, things fell apart. Our research included investigating polarity and how it relates to waterproofing. We also researched various non-polar molecules, materials, their properties, and how appropriate they were for our project. This research included the use of 2 peer-reviewed journals. This project was a phenomenal learning experience. We learned the importance of working as a team and that doing so is much easier said than done. We also gained experience in modifying plans to meet unexpected obstacles. In addition, we became very familiar with the horrible smell of melted beeswax and the nightmare it can be to clean up. Most importantly, however, we learned how to use the engineering design cycle ourselves. In this presentation, we shared the objective of our Fabric Bucket Challenge, showed how we used the engineering design cycle to form a solution, displayed our research, shared what we learned through the process, and lastly, here are our references. We hope you enjoyed our presentation of our 2015 FEDD project.